Good morning, ninjas. How is everybody? Happy Friday. Hope everyone's been enjoying Shark Week this week. I love Mauricio's talk on Monday. Personally, that was really, really awesome, as well as Tanya's yesterday. So today, we're going to get into some shark history. Then tomorrow, we're teaching a special Project Aware shark conservation course with Dive Ninjas. I'll be teaching it as well as Ellen. So there's a couple spots left on that if you'd like to jump in and join us on it or anything like that. We cover a bunch of stuff from, shark biology all the way out to threats and how you can get involved and how you can help sharks and all that. Then next week, we've got something very special planned. We've got an entire week devoted to cetaceans, so whales, dolphins, marine animal rescues, the vaquita, and more. Lots of really cool stuff. We kick it off on Monday with Ted Cheeseman, who's the founder of Happy Whale. If you're not familiar with Happy Whale, it's an online platform that crowdsources citizen science data from whales all over the world to be able to track them and everything like that. It is an incredible, incredible project. Then we've got some talks on, like I said, marine animal rescues, the vaquita, dolphin sanctuaries, and lots more cool stuff. Then at the end of the week, we've got a very special Dive Ninjas Whale Defender course next Saturday. This is an online course that we created out of our Whale Defender program here in Cabo San Lucas with Sea Shepherd. So with that, we talk about whale biology, evolution, the complex history they have with humans, the threats they're facing, and how you can help protect these gentle giants. So that they can continue to roam our oceans for many more millions and millions of years. But let's rock and roll with some sharks. So Frida, are you ready? How you doing today?
Hello, yeah, I'm ready. I'm very excited to talk about this today.
Awesome. Well, we're glad to have you. Thank you for joining me today and helping me with this. So today we're going to do it a little bit different than we normally do. Frida and I have been working on building this presentation together because we kind of wanted to look at the history of sharks, and there's sometimes, bizarre adaptations and evolution and all this, as well as how we know what we do know about them and how, we understand where the Megalodon came from, when it was here, or when these other sharks were around and all that. Then we're going to finish up by looking at a couple other apex predators that most likely competed with some of our favorite historical sharks. So let's sit back, grab that cup of coffee, and we'll get rocking. So first up, like I said, we've got brilliant and amazing shark scientist, Dr. Frida Lara, joining us today. So Frida, why don't you tell us a little bit about yourself?
Yes, well, I'm Frida Lara. I'm a shark scientist. I work in Pelagios Caconja, and I'm a member of Migramar, that is a network of researchers that work on migratory species in the Eastern Tropical Pacific.
Awesome. Thank you. Thanks for joining us today, and thanks for the help with this. For those that don't know me, or maybe you only know me from ocean stories or anything like that, my name is Jay Clue. I'm a shark lover to start. I'm also a conservationist and underwater photographer. I founded Dive Ninja Expeditions a few years ago with the idea to kind of create an ecotourism platform that could bridge the gaps that we kind of find between tourism, science, and conservation. It was in hopes of utilizing tourism as a way to protect the animals and ecosystems that bring us these amazing experiences and that we all fall in love with. I primarily work with pelagic animals, so sharks are always on top of the list, which is actually how I met Frida a few years ago through a citizen science project. But it's amazing to see how much has happened in these last few years. I mean, Frida, you finished your doctorate, which is incredible. Congratulations again. That's freaking awesome, you know what I mean, since we've met. So many awesome things going on in these last few years. And right now, Frida and I have been actually working on another special project for Dive Ninjas that we'll be announcing in the next couple weeks. I can't say too much about it right now, but it'll be coming out probably in about 2 weeks or so. But I give you a little bit of hint. It involves one of my favorite sharks, and what also happens to be the fastest shark in the ocean. But that's all I can say right now. So we'll rock and roll. I'm guessing most of you are here today because you love sharks in some way, just like me and Frida. We hear about sharks all the time, We've had lots of great talks on ocean stories these last 6 weeks, learning about, the incredible abilities of sharks, their hyper-evolved senses, their reproduction, the perils they face, the threats they're facing. I mean, just the other day, one of the largest shark seizures of shark fins in the history of Hong Kong was happened. 26 tons of fins were captured, most of them actually from endangered species. But why do we care? This is something that I always find to be like a bit of I don't know, a bit strange. Like, why do we love sharks so much? Beyond the critical roles that they play in our oceans, there's just something about sharks that captivates us, that draws us in. I mean, maybe it's the curiosity of these ancient creatures that are still roaming our oceans, but have been around since, you know, before trees existed on land. Or maybe it's that strange love of the fear that they instill in people. Or, you know, maybe it's just the admiration of an apex predator that's made it through 5 mass extinctions. Whatever it is, I think we can all agree that they're remarkable creatures. When I first heard this quote by Captain Paul Watson, the founder of Sea Shepherd, it really kind of took me off guard. I'd never really thought of shark evolution or even evolution in that kind of way. And to think like so many of our ocean creatures have essentially evolved in all these different ways just because of sharks. He says that sharks have molded evolution for 450 million years. All fish species that are prey to sharks have had their behavior, their speed, their camouflage, their defense mechanisms, all molded by the shark. And this is incredible to me when you start to think about it, how many adaptations and everything and how many animals have been affected just by this one creature, you know? But it then begs you to kind of wonder, if they had such an impact on everything else, where did they come from? And what impacted them? How did we get to these modern day sharks that we love to see and dive with and we all want to save and everything? So before we can really look at how they got here, we need to understand how we know what we do know about the ancient ancestors of sharks. I mean, sharks belong to a group of creatures known as cartilaginous fishes because most of their skeleton is actually made of cartilage instead of bone. The only part of their skeleton that's not made from, you know, this soft, flexible tissue of cartilage is actually their teeth. And this picture here is actually the jaws of a Megalodon. So shark-like scales from the late Ordovician, and I apologize for if I murder lots of these words. I am not a scientist, and my Latin and words are very not very good, but we'll try my best. But we've had scales that have been found, but no teeth from this era. And if these were from sharks, which suggests that the earliest forms could have been toothless. They may not have had teeth at all. Scientists are still debating if these were actually true sharks or shark-like animals. But the vast majority of shark fossils that we find are actually teeth. And this comes down to 2 reasons. One, it's because the skeleton of the sharks is made from this soft cartilage that we spoke about. It takes special conditions for this cartilage to actually preserve, so it's really difficult to find them. The teeth, however, are made from a much tougher material. It's known as dentin. This is like a harder, denser material. It's actually harder and denser than even bone. And it helps enable a powerful bite for the shark, but it also increases the chance that the teeth will fossilize as they're less likely to decompose. The other reason is just simply numbers. Rather than having just a few sets of teeth that last their entire life, sharks are actually continually producing new teeth. And as one gets older and breaks or wears down, it simply falls out of the front of the mouth and onto the sea floor. And a new tooth then takes that tooth's place. Shark teeth are embedded in the gums rather than directly affixed to a jaw. And they're constantly being replaced throughout their life. Multiple rows of replacement teeth are actually growing in a groove on the inside of the jaw and continually move forward in comparison. It's kind of like if you think of it like a conveyor belt, there's always a new one coming from the one that's worn out. So as one wears out and goes away, another one is appearing coming from behind. Depending on the species and the diet of a shark, over its entire lifetime, it can produce somewhere between 20,000 and 40,000 teeth. That's just one shark. It's incredible. Some sharks actually lose the entire set of teeth they have every 1 to 2 weeks. So imagine how many teeth there are coming out of them all the time, you know what I mean? And why we can find them so easily. So this means there's a much greater chance that a shark tooth would be preserved and turned to a fossil because there's just so many more of them. And not only are the teeth, you know, the most common part of the sharks to be found, they're also one of the most common fossils of any organism ever found. I mean, out of all organisms on Earth. So the first shark-like fossils that we found are what we call dermal denticles. These are the skin scales that we have on sharks. The first ones were discovered in the Harding sandstones in Colorado, as well as in the Carmichael sandstones of the Stokes Formation in Australia. The interesting thing to note here is that only the dermal denticles have been found. We've not found any teeth. So jawed fish were just developing at this time. So the first sharks may have had no teeth at all, or might not even have had jaws. It appears that teeth developed later on in history. So according to the fossil evidence, a shark tooth is simply just a modified dermal denticle, albeit a great big and sharp modified dermal denticle. But they follow this same thing, the same features. These ones here, as you can see, the bar at the bottom is only 0.5 millimeter. They're very, 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 very tiny. But the teeth of the sharks are, like we said, are the most common fossils we find. These ones here belong to Otodus obliquus, which is an ancestor of actually the Megalodon. But before we can really get into the evolution of sharks and talk about their teeth, we need to take another step backwards. And we got to first understand a very special fish, one that basically all sharks can trace their heritage back to. It would be like the great-great-great-grandmother times 1,000 of modern day sharks. Except it's not really a shark. It's more like a missing link between sharks and other fish. So enter DOLIODUS problematicus, which is the greatest name of a fish I think I've ever heard in my entire life. This is the earliest shark-like teeth that we have come from the earlier Devonian era. It comes from a fossil of these guys, and they belong to this ancient fish. In the mid-1990s, a 400-million-year-old DOLIODUS skeleton was discovered in the Canadian province of New Brunswick. But it wasn't until 2014 that technology advanced enough to allow researchers to be able to see that the specimen actually had shark-like jaws and tooth arrangements. As its name suggests, it was a problem even before they found this actual fossil. Paleontologists had turned up plenty of its teeth over the years, but they weren't certain whether they fit to a bony fish or shark or something, or a ray, or etc., until this fossil turned up and they were able to do the research on it. This fish can actually be described as maybe the least shark-like shark that we know. And it's thought to have risen from within a group of fish known as acanthodians, or spiny sharks. These sharks are very different than the sharks we know and love today. To start, they were not at all shark-like in shape, as you can see. For example, they did have their scales were more diamond-shaped, and they had these spines in the front of all their fins. You can actually see it on the pectoral and dorsal fins of the illustration here. They were also a lot smaller, and some of them even lived in freshwater. So to the untrained eye, they looked very much like a bony fish. But in 2017, this team of researchers were able to figure out that Problematicus was actually the missing link between sharks and fish, and bony fish. It was actually that step in evolution where the fish started to head down the shark pathway. So this is where I'm going to hand it over to the experts. Frida is going to teach us a bit about how modern sharks have evolved from this strange missing link from 400 million years ago and into what we know of them today. So Frida, I'll let you take it over.
Yes, of course. So the origin of the sharks started 450 million years ago. The sharks appeared in the late Ordovician period, and the first fossils that they found, like really like true sharks, were found in the Siberian deposits. In this time, the levels of the sea were high, and the coral reefs were just become like a real ecosystem. The earth was warm and very stable, and the mollusks and the crinoids and the trilobites were very common. All started with the Leodonus shark. This is in the Devonian period, 450 million years ago, and this is the real elasmorang that we can recognize. They had, as Jay said, they were, according to the morphology, they are related more to the freshwater than the ocean. That's very interesting. And they were found mainly in the southern hemisphere, in the Antarctica and Australia. Then we have the unicorn shark. they were appeared in the Carboniferous era 360 million years ago. And this is called the golden age of sharks. This is because it's the time where the three main groups of elasmobranch split into the chimeras, the sharks, and the rays. So according to the fossils, the sharks had at least 3,000 species at some point in the history. So after that, we have the Jurassic Era. This era was very important because it's the rise of the modern sharks. This was 2 million years ago, 200 million years ago. And this time is when we have some of the new species, the modern species, like the three-legged shark. And this, especially in the Jurassic period, is when we have like a mass extinction of different species. And is when the ones that survive are the modern species that we know now. After that, in the Cenozoic era, we have the Megalodon. The Megalodon appeared 60 million years ago. And in this time, the sharks were one of the most successful species on the ocean. So they were conquering the ecosystems, and they were, as Jay said, they were shaping the evolution of other species. Then we have a very famous extinction, the Mesozoic Era, in the 66 million years ago. This is the big meteorite that just fall into Yucatan, and probably it was one of the reasons for many species in land and in the ocean to extinct. And the only sharks that survived to this extinction were the sharks that we know now. After that, in the 20 million years ago, the Mesozoic area, we have modern species like hammerheads. This is one of the last species that appear according to the records. So we can say that it's one of the most modern ones. So in the next one, why, this is one of the questions that we always ask. Why these sharks and how they survived to these 5 massive extinctions over the 400 million years. So according to the studies, sharks were in different habitats, and they had different food habits, so they had different prey. And the sharks that had the adaptations to survive to different ecosystems and to different conditions were the ones that were able to survive and then diversify into other species. So that diversification and adaptations in shapes and bodies allowed them to be able to exist until now. Next. So the modern sharks, if we compare it to the previous species like Megalodon, are much more smaller. And this is one of the very interesting questions. Why sharks shrinking at some point? So according to the studies, we found that this is related a lot to the prey and the ecosystem where they live. So if the prey that they eat is smaller and it is very related to the ecosystem, then the sharks tend to be smaller too. They have to adapt to the area and the habitat where they live. So in some studies, there are some theories that the sharks are actually gonna shrink more in the future. So to take you to some of the very interesting characteristics, Jay is gonna tell you more about the Megalodon.
Awesome, thank you, Frida. So let's talk about one of the sharks of some people's nightmares, other people's dreams, the Megalodon. So the Megalodon was not only the largest shark to ever exist in the world, but it's also one of the largest fish to have ever existed. Estimates suggest that it grew to between 15 and 18 meters in length. That's up to 60 feet long, and it weighed over 60 tons. To put this into perspective, that's 3 times longer than the largest great white shark that we've ever heard of, and 20 times heavier, making it one of the largest predators to ever live on Earth. Now, some of you might say, well, sperm whales are a bit longer, but they actually weigh less. So for those on Team Whale, you're going to have to take a silver medal on this one. If you look at the chart on the side here, you can see that you've got the upper estimated size of the Megalodon on the left, and then on the right, the lower estimated size of it. The shark underneath it is the whale shark, which is the largest living fish that we know of today, as well as next to it, the great white. And the little purplish blue dot there is a scuba diver. So you can kind of just, to put it in perspective, imagine seeing this creature in the ocean and it's swimming by you. It being bigger than a whale shark. For those of you that have been snorkeling or diving with whale sharks, you can imagine something bigger than a whale shark, but that is a proper predator, proper apex predator. The name Megalodon simply just means large tooth. That's what the name comes from. The sizes that we estimate them is actually based on these fossilized teeth. We don't have any complete fossilized skeletons that exist. They have, however, found some fossilized Megalodon vertebrae, which are actually about the size of a dinner plate. It's huge, but we don't have any actual skeletons. So we're basing everything off of these teeth. The largest Megalodon tooth that's ever been found was about 7 3/8 inches. So to put that in perspective, the largest great white tooth is about 3 inches. So it's more than double the size. And Megalodon's teeth weren't just large. It actually had many and many, many of them. Its jaws were lined with around 276 teeth organized in 5 rows. So a lot of teeth and a lot of very big teeth. They were also adapted to warm and subtropical locations around the world and spent most of their time hunting at the surface. The species is actually so widely spread that Megalodon teeth have been found on every continent around the world except for Antarctica. So how do we know, what do we know about them? The earliest Megalodon fossils we have, they date to around 20 million years ago, as Frida was just saying. For the next 13 million years, this enormous shark dominated the oceans until becoming extinct around 3.6 million years ago. As more and more fossils have been found, we've realized that the ancestor to the great white shark actually lived alongside the Megalodon. Some scientists think they might have even been in competition with each other. Great whites appeared around the same time that Megalodon started to disappear. With its large serrated teeth, the Megalodon would have eaten meat. I mean, it was definitely a carnivore. And it most likely ate whales, like huge, big whales, large fish, and probably other sharks too. And if you're that big, you need a lot of food. So they would have went after large prey. This would have included animals as small as dolphins, but as large as humpback whales. We also have other evidence of Megalodon's feeding habits in the form of fossilized whale bones. In some of these whale bones, they actually find the cut marks of Megalodon teeth etched into them. And others have actually, they've even found the tips of Megalodon teeth broken off into the bone from an attack that occurred millions of years ago, which is incredible. They can almost put it back together like with CSI or something. Unbelievable. But what caused these ocean titans to vanish from our oceans? Why aren't they here anymore? We know that Megalodon had become extinct by the end of the Pliocene era, when the planet entered a phase of global cooling. Scientists think that up to 1/3 of all large marine animals, including 43% of turtles and 35% of seabirds, all became extinct as temperatures cooled down. And the number of organisms at the base of the food chain would then plummeted. This kind of resulted in a domino effect working all the way up to the top of the food chain with the apex predators. The cooling of the planet may have also could have contributed to the extinction of the Megalodon in a number of different ways. As the adult sharks, they were dependent on these tropical waters. So the drop in ocean temperatures likely resulted in a significant loss of their habitat. They wouldn't have been able to travel as far. They would have been, more constrained. It may have also resulted in the Megalodon's prey going either extinct or adapting to cooler waters and moving to there so the sharks can't follow them. So, such as, warm-blooded whales migrating further towards the poles, and then the Megalodon unable to actually follow them into these cooler waters. Whales have the ability to thermoregulate, because they're warm-blooded and everything, and they migrate towards these colder waters, as we already know. While the exact thermal regulatory capabilities are a bit of a still topic of current study, this inability to hunt whales in cold water is believed to be one of the leading causes of megalodon extinction. It's also thought that Megalodon gave birth to its young really close to shore in tropical waters. This always makes me think of like being on an island in the Bahamas and getting in the water and seeing, baby Megalodons swimming by me that are 5 meters long or something like that. Sounds like a dream. But these shallow coastal waters would have provided a very nice nursery for the pups. It would have protected them from predators that were lurking in the open ocean, like the larger toothed whales and everything. But as ice formed at the poles, the sea levels began to drop. And these pupping grounds would have then been destroyed. They would have disappeared. So the latest research estimate that their extinction happened around 3.6 million years ago. But one theory shows that great whites arrived around 4 million years ago. And this could have been a direct competition for resources that have already become scarce, as well as the arrival of tiger sharks, which would have also called the Megalodon's pupping grounds home. So the tiger sharks could have been preying on the pups of the Megalodon. And great white sharks, they're much smaller than the Megalodon, as we just learned, but they could have competed against the juveniles. And other changes in the ocean at the time could have then been like just enough to make that difference. So the Megalodon's already dealing with dwindling populations, losing their prey and everything like that, and they're starting to shrink into smaller and more fragmented populations around the world. And under these threats, the appearance of new competitors like the great whites and the tigers could have actually been the final nail in their coffin. So let's look at a couple really interesting facts about these guys. The first one is that most people don't know is Megalodon actually helped invent modern geology. For centuries, people would dig these strange objects out of the rocks in Malta and the Mediterranean. These rocks were known as glossopetrae, or tongue stones. Pliny the Elder felt that these tongue stones fell from the heavens during an eclipse. Then in the medieval legends later on, they attributed these tongue stones to St. Paul casting a curse on the island serpents. But nowadays, it's actually generally agreed that most of the larger tongue stones that they were finding were actually megalodon teeth. In 1666, a guy named Nicholas Steno, who was a physician at the Florence court, was given the head of a shark to dissect. As he was dissecting it, he noticed that there was similarities between the shark's teeth and these tongue stones. Although others were doing similar work before Steno, he became interested in how the teeth got into these rocks. And this would lead to more general work in geologic theory and how layers of rocks form over millions and millions of years. Today, Nicholas Steno is referred to as the father of stratigraphy. The Megalodon's jaws are actually estimated to span 2.7 by 3.4 meters wide. That's over 10 feet for those working in feet. It's easily big enough for 2 adult humans to just enter side by side. As you can see, this picture in the corner of one of the researchers from one of the first reconstructed Megalodon jaws. So these predators were massive and they needed a lot of food. It's estimated that they ate over a ton of food per day just to sustain themselves. They're also considered to have one of the most powerful bites of any species ever known. To put this into perspective, humans have a bite force of around 1,300 newtons. A great white is predicted to be able to bite down with a force of about 18,000 newtons. But researchers estimate that the Megalodon's bite force could be somewhere between 108,000 to 180,000 newtons. That's insanely strong. To put that in even more perspective, Tyrannosaurus rex that we all know with the fun short arms and giant jaws, this bite force would have been 2 to 3 times stronger than the T-Rex. Another fun fact is that the picture that most of us actually have in our head when we think of Megalodon is wrong. A lot of reconstructions have Megalodon looking like a bigger version of the great white shark. And this is because for a long time, people thought they were actually related. But we know now that this is not the case. And Megalodon is actually from a completely different lineage of shark. which Megalodon was actually the last member. The Megalodon likely had a much shorter nose and like when compared to the great white, with a more like flat and squashed jaw. And then like the blue shark, it also had extra long pectoral fins to be able to support its weight and size in the water. And it was not, Megalodon was not only the only giant shark of history. There's actually many more giant sharks, as well as large predatory fish and a huge sperm whale with teeth that were the size of a 2-liter bottle of soda during this period. But we'll come back to them a little bit later. And the last fun fact I want to share about them is that there's also a group of bivalves, like small hard-shelled mollusks, that emerged in the Devonian period and died out in the Jurassic, whose genus name is actually Megalodon too. But I don't think we can count on seeing them in any big budget Hollywood films anytime soon. Although the picture of a Attack of the Giant Clam, poster to me sounds amazing. So this leaves many of us wondering, could Megalodon still exist? There's a lot we don't know about the oceans. The oceans are insanely deep. There's so much, we don't understand about them and everything like that. Could it be hiding in the depths, waiting for a triumphant return, buying its time or anything like that? Well, I'm sad to say, but no matter what the Discovery Channel has told you, it's not possible. Megalodon teeth disappeared from the fossil record about 2.6 million years ago. So as we learned before, with all these teeth and everything like that, it would be hard to not have any now. We would not be seeing any now. And a hungry predatory beast the size of a school bus would put a pretty big dent in marine ecosystems. And most likely the commercial fishing industry would notice this. They would take notice of this. And despite what the Discovery Channel has also said in the past, they're not really suited for living in the deep oceans. They were a warm water species and would not be able to really survive in the cold waters of the deep, where it would have had, a better chance of hiding from us and going unnoticed. Plus, as we learned earlier today, they also fed near the surface, so they'd be easily seen. So if an animal, as big as Megalodon still lived in the oceans, we would know about it, we would see them. The sharks would also leave telltale bite marks on other large animals. Even if for some reason we weren't able to see them or anything like that, we would still find these bite marks on other animals and bones and things like that. And their huge teeth would continue to be, all over the ocean floor in tens of thousands. So that's for Megalodon. Let's look at some other really awesome sharks that come out through history. Frida, can you tell us a little bit about these strange unicorn sharks? Did they have any magical powers or anything like that?
Yes, of course. So I'm gonna tell you a little bit about other species of sharks that were prehistoric. This one is one of my favorites, is the Phalicatus. It's a species that was very small compared to the Megalodon. It was 25 to 30 centimeters, and it had a very clear sexual dimorphism. That means that the females and the males were totally different. They first found males with a characteristic spine that was this kind of like horn, like a unicorn horn. But what they found later was fossils of the females and the males together mating. So actually this horn was a sexual organ that the males used for mating. The females were biting this horn and then they were able to mate. So it was very interesting. They appeared 270 million years ago. And yeah, the next one. This is one of the other sharks that I find very, very interesting. This is the HELICOPRION. This species had a saw jaws. So imagine that instead of having like a normal jaw, like other sharks, they had a large spiral of teeth. And what they did was to open the mouth and get the prey and swallow it. So it was very interesting. They according to the fossils, they didn't have any damage on the jaws or on the teeth. So that means that probably they were feeding on squids or other animals that were not very big. So despite they look very aggressive and like a very big apex predator, they weren't. The size was around 7.5 meters long, and it was very interesting. They had many species and many variation of this saw. The next one is the scissor tooth. The Edestus shark, Edestus giganteus. It was a species that the only part of the body that has been found is the row of the teeth, the inferior one or the superior one. So the actual way that they were preying is just an speculation. We don't know exactly how they were preying, but what we think is that they were cutting their prey and trash it and then swallow it. So it's a very unique species, and is the only species in the marine life that we know that was eating like that.
Awesome. Thank you, Frida. So let's check out the two more predators. These are not sharks, but two other really cool predators that lived around the same time as Megalodon. Some of these guys, they actually believe that they competed with sharks, and some of them actually even preyed on sharks. The first is this one. His name is actually the terrible fish, which I find hilarious in some ways. But this fish actually grew up to 20 feet in length. You're talking about 6-7 meters long, and it weighed more than a ton. It was equipped with these crazy jaws and teeth, as you can see in the picture, and it was able of chopping prehistoric chums into prehistoric sharks into pieces, into chunks. Really, really crazy, freaky looking fish, and really like hard armored head and everything like that. The only advantage that sharks had at this time to escape a fish like this was their high speed, because since they were armorless, sharks were more sleek and more agile. They were able to move quicker and get away faster and everything like that. Then the last one I want to look at is this guy. We rarely think of whales as these hardcore apex predators. But this extinct genus of sperm whale may have actually competed with the Megalodon for food. It's received its genus name from the biblical sea monster, the Leviathan, and its species name actually comes from the author of Moby Dick, Herman Melville. Its total length has been estimated to be about 13.5 to 17.5 meters long, so around 44 to 55 feet, something like that. It's almost the same size as the Megalodon, but it weighed a bit less. But the most incredible thing about the Leviathan is that its teeth measured 1.2 feet. It's like, this big, or 36 centimeters. That's essentially the size of a 2-liter bottle of soda. They're the largest biting teeth of any known animal to have ever existed on Earth. Can you imagine an animal with teeth, like rows of teeth like this? It's incredible. So yeah, that's all we've got for shark history for today. Thank you everyone for joining us and everything like that. Let's open up the floor for some questions. If anyone has any questions, throw them in the Q&A box. We're gonna do our best to answer them. I mean, we are not shark history researchers or anything like that, but we want to try to do something different, so we're gonna try our best. Throw them in the Q&A box. I'll read them out and we'll rock from there. So, let's see. First question's coming in. Morgan asks, thanks for this awesome talk. Are there any books about historic sharks you would recommend to add to the collection?
Yes, I think there is a famous geologist, Roy Troll, and he was a very famous painter. He loved to actually draw all these models of sharks. So I would recommend you to look for his books. He's very interesting to see all this diversity of ancient sharks.
Awesome. So Jose La Rosa asks, thanks for this great shark history talk. What do you think may have kept Megalodon numbers in check during their peak? The Leviathan or pods of orcas, or do orca overlap with Megalodons on the evolutionary record at all?
What do you think, Jay?
I'm going to say, I think part of it would have had to do with the amount of food that they have. You know what I mean? That would be my guess is, since they need such a large amount of sustenance, you know what I mean? That they were, essentially the apex predator of the time, that tied with, like environmental conditions would have probably kept their populations from being able to maybe explode and, wipe everything out in the meantime.
Yeah, probably their life cycle was also very long. So
Mhm.
probably as the great whites, they should have very few pups. So in order to get to the mature age, probably took a long time. So that also regulates their population.
No, very true. Yeah, sure, definitely.
Mhm.
As for the orcas overlapping with megalodons, there were similar like animals. They're not orcas exactly, at least from what I was reading. But you know, similar animals, but they were much smaller. They wouldn't have been something that could have gone after a megalodon or anything like that. They would have been more of prey for the megalodon. Cool. So Sue says, Frida said that sharks are likely to be getting smaller. Why is this?
So according to the studies, the idea is that the preys are changing, the environment also is changing. So sharks adapt very fast, and that's the trend. So if you compare the average size of the sharks million years ago to the sharks today, they seems to be smaller. So the response for that, it will be that they adapt to the environment and the prey that they eat. So it's very interesting to see that.
Really interesting. And she continues to ask the second question. She says, particularly then when the megalodon preyed on dolphins and whales, how come modern sharks aren't evolving to prey on cetaceans and start to get bigger again?
That's a very interesting question. Some of them actually, like tiger sharks and great whites, have been recorded feeding on sperm whales or gray whales, and so they are able to do it, but the chances for doing that are so small that I don't think their primary prey are the whales, but they potentially can prey on them.
Awesome. So Logan asks, is there another shark that is close to the size of the megalodon?
In like now, no.
Wow.
In the past, there were a couple of cousins or similar species that were part of the same group, and they were maybe not as big as the megalodon, but something like that.
Yeah, there
But
was a bunch that were pretty close. Some that were relatively close, still not as gigantic, but they were, you know, ones that actually got up pretty close in size and everything like that.
yeah.
Awesome. So Fernanda asks, has a jaw of the megalodon been found intact with the teeth next to it, or are they just all assembled?
What do you think, Jay?
Well, from what I've read is that there's no real full jaw skeleton or anything like that. Most of it's actually been assembled and put back together. They do have parts, they do have pieces of them and everything like that. There was one, I want to say it was found in Peru, if I remember correctly, that was more intact, you know what I mean? As well as ones from other species that are a bit more intact. But most of it is not, there's no complete set. Like it's not a perfect complete set. It's bits and pieces that they've been kind of putting together from like a puzzle in a way.
Yeah, it should be very hard to find one that is intact.
Yeah, imagine finding that though, like you're just going through some rocks one day and you just come across this gigantic, you know, 3.5 meter jaw, just like sitting in the rocks, like that would be incredible. So cool. Anonymous asks, I work at an ocean camp, and one question I always get from the little kids is, how can you be sure Megalodon doesn't exist anymore, especially when so much of the ocean is undiscovered? How do you answer this? Well, for me, the way I would answer it is that one, they lived at the surface. You know what I mean? They were warm water animals. They don't go into the deep and the cold waters and all that. They actually can't live there. So we know that they wouldn't be able to exist there. We also know that, like, because of they had their pupping grounds near to shore, we would find the pups, you know what I mean? And also because there's just no teeth. All the megalodon teeth that we found, like they're found in the world, they stop at 3.6 million years ago. So there's been, in the last 3.6 million years, there hasn't been any tooth found of a megalodon. So there's no way that they would be there unless they're, you know, they've got a tooth fairy coming along and picking up all their teeth or something like that. But also too, it's just the prey. You know what I mean? If we don't find that, you know, they're whales with scars or markings from like a massive animal or any of these kind of things, there's no way to see it because they would still need to eat these very large predators. But the main one is that, you know, since they were a warm water species, they wouldn't be able to live in deep water. So we would be able to see them. We would find them at the surface. Like we, you know, think of how many whale sharks we find in the world all the time, you know, and everything like that from hanging out at the surface. Hopefully
also the fishing, no? Like in terms of all the industrial fishing, probably they will be able to catch them by accident, by bycatch. So.
No. Now that would be some crazy bycatch.
Very accidental bycatch.
But yeah, with all that, with the commercial fishing, as well as all the the deep exploration that they do for mining and for oil and all these kind of things, you would think they would find something of that. You know, I mean, something of that size would either need to be, you know, actually spotted, or, you know, you would find remnants of it in the sense of like larger animals that have been predated by them or something like that. Cool. Enrique says, thank you for the great talk, Jay and Frida. This is not a question, but rather a comment. Now, I know better how to explain to my school kids that megalodons are not around these days. It is a question that shows up frequently because I talk to them on scuba diving and ocean stuff. Awesome. Thank you, Enrique. We're glad we can help. I would love to know what their response is, though, when you're there. And the same for the last question, too. Let us know how it goes with the kids, what they say after you explain these things to them.
Not totally convinced.
Yeah, exactly. I have a feeling they probably still won't be convinced, but would love to know what their responses are.
Yeah.
Awesome. So Laurel asks, are there any current fish with those hard plates?
Nowadays, well, I think there are some species that could be similar, but not as the same as we showed. Like the size and the adaptations were totally different to a different place and a different environment.
Yeah, I don't think we have really any super hardcore giant armored ones coming around. I'm trying to think. There's one that is popping in my head, but I can't think of the name. It's on the tip of my tongue. But it's a very small fish that has a bit of armor kind of plating and everything like that. But nothing that would have been to the extent of these animals.
Yeah, actually, the species that could be so like similar to them should be like 20 centimeters long, because they adapt to the environment, and that was the only way they were able to survive to the massive extinction. So the smallers were the strongest at the end. Yeah,
exactly. The ones that make it through. Awesome. That's what I love when I had a talk with Dr. Bob one day, Dr. Rubin, where we were talking about the evolution of sharks and mantas and these things. And he was telling us how like most modern sharks kind of evolved from like, you know, essentially like an ancestor of like small horn sharks, you know what I mean? Like, which is incredible to think that these tiny little kind of lazy sharks are like the, you know, the great grandmothers and grandfathers of like great whites in makos and stuff like that. It's like they went from being lazy and hanging out under rocks to being like these crazy apex predators again. It's mind-blowing. So Laura asks, what other fish have buzzsaw jaws? And thank you for the great talk.
I don't know. It's hard to think about. For example, do you know?
For me, no. I mean, the only one I would know of is the HELICOPRION. I mean, that one shark, the ancient shark. I don't know of any in modern time or any other throughout history that have that weird adaptation. I would almost be curious to figure out, and I know nothing of the paleontology on this or anything like that, but that if like the scissor tooth and the HELICOPRION were in some way, you know, genetically related, or they came like from the same lineage or something like that, since they have that same kind of, you know, strange tooth setup.
So, yeah.
But yeah, sorry, I don't know any others at the moment that have that. Cool. So Christine says, so when did they first find some of these extinct sharks, like the unicorn or the terrible fish? And was it all over the world, depending on the species?
According to what I found, yes, the fossils are found primarily in deserts or in places that are colored time windows, places where there is a big accumulation of fossils of different times. And they are, for example, in Texas or in Australia, in these ones in the Siberian deposits. And it's very interesting to see all these different ages according to the geology. So once you go deeper, you can find older sharks or other like proofs of how was the environment in that time. So it's pretty cool.
That's awesome. Really, really cool. All right, so Cesar says, hey, awesome presentation. I'm really starting to think about to start diving with sharks. I have two questions. By any chance, do you know if there are any policies involving not fishing or hunting sharks?
Yes, there are, it depends on the country. Each country has their own rules, but for example, here in Mexico, the three species that are fully protected are the great whites, the whale sharks, and the basking sharks. That is very interesting because it's very infrequent to find a basking shark in Mexico. But the other species, there is like a regulation by CITES, that is the organization that regulates all the trading of wild species. So the ones that are vulnerable or endangered are controlled by this organization.
Awesome. And then his second question is, could you recommend a book about like fantastic animals in the ocean, such as like the Kraken or the Leviathan or something like that? Do you know any books about them?
Well, mainly what I found was from national history museums. So they are the ones that keep the records, and they are doing the research on all this geology and paleontology. So I will look on the websites of these natural history museums. Probably you can find more, for example, the one in London or New York. Probably they have a lot of information about it.
Awesome. And there was, I can't remember the name of it, and I apologize for that, but there was a book I've seen a long time ago that looked at like the history of sea monsters. And it was kind of looking at like what people thought, what humans thought, like then, you know what I mean? Like it was this crazy giant dragon that came from the ocean and tried to eat my ship. And then comparing it to what we know about the history of marine animals now and everything like that. So, I mean, maybe it wasn't a giant dragon, but it was a blue whale, you know what I mean? And these kind of things. I don't remember the name of the book, but it was something about sea monsters, like the history of sea monsters or something like that. It was very interesting how they told you like the legends, you know what I mean? And then looked at like what it could have actually been or what could have inspired it from history and these kind of things.
Yeah.
Cool. Sarah asks, thanks for this interesting talk. In which part of the world were found the fossils and teeth of the Megalodon? The Megalodon teeth have been actually found everywhere, like all over the world. They've been found all over, everywhere, like on every continent except Antarctica. There are some places where they find them a lot more, like in the Carolinas and these kind of things. In some regions, there's just tons of them. And you can actually go diving and looking for them and these kind of things, or finding them in riverbeds and this kind of stuff. But they're pretty much, yeah, on every continent in the world, you can find them, except for Antarctica.
Even here in Baja, have you heard about it?
I would love to find one here in Baja.
Yeah.
I would love to find one in general. That'd be amazing.
Yeah.
Awesome. So Sarah asked, oh no, sorry, I just read one. She said, how come the unicorn shark bodies, male and female, were found? Is the unicorn not cartilage?
Well, sometimes I think it depends on how they were preserved. So I can share with you some of the images that they found, but you can see probably like the vertebra and some of the tissues that probably were preserved depending on how they were there and how they stay in the rock. Sometimes you don't see the skin, but you kind of see the shape of the body, no? So it was very interesting because before it was just a speculation, but when they found the two together, they knew why, like the function of this organ. So it was pretty cool.
That's amazing. Really incredible. And amazing that they were able to find the two of them together, like how that could have happened, you know, whatever the event was or whatever that could have stopped them, you know, not just killed them mid in the act, but also been able to fossilize them right in that, you know, spot and everything like that is just mind blowing.
Yeah.
Anonymous asked approximately how many of these teeth have been found. With the Megalodon, I mean, they find quite often, well, all shark teeth are found pretty often. With the prehistoric or ancient sharks and these kind of things, they're still finding them every day, almost all the time here. There's actually places in the world you can go diving. They do like Megalodon teeth dives and everything. They're that common, like in the Carolinas in the US and these kind of places where you can actually go out and look for them. And all that stuff. So they're relatively common. Shark teeth are, you know, like I said, they are the most common fossil of any animal on Earth.
And it seems like there is a lot of people that collects megalodon tooth, but now there are some regulations. For example, in Mexico, I think it's illegal to sell the tooth because they are considered as part of the National Archive or something like that. So it seems like it's more regulated every time.
Awesome. Yeah, that's really good. Because that's one thing I always wondered is like, I mean, obviously they are finite. They will run out at some point, and you see all these places that you can go and do like, you know, Megalodon dives and these kind of things, and super cool. Like, it's an amazing thing. But I wonder then, like, do they take it home, or do they say, okay, we found these teeth today, we're going to give them to the researchers, and if the researchers don't need them or don't want them, then okay, you can keep them. Or if it's just like, cool, I found this, I'm taking it home and putting it on my, you know, mantle or something like that.
I met once a guy that told me that he was a collector of megalodon tooth, and he told me that he knew from where was coming according to the color. So some of them are like clearer, or they look like amber or very dark. So the people that is obsessed about collecting them, they know from where they are coming. So it's pretty cool.
Oh, that's amazing. That's
Yeah.
really, really interesting. Awesome. So Logan says, I'm 10 years old and I love sharks. I want to fight for the shark species. They're the coolest things. Thank you for the video. Awesome, Logan. That is great. Super, super cool. Keep up the great work. We need more people like you out there. All right. Awesome. And then Fernanda asks, is the frilled shark related to the basking shark? They kind of look alike. Great talk. Thank you.
I'm not sure. Probably we have to look for more information. As Jay was saying, there is a lot of information that came from the fossils, but nowadays we also know a lot about evolution because of genetics. So many of the species that before were not related at all because they have a very different morphology, now we can track them by the genes. So it's very interesting to see how all this history is going to change according with this new science.
Awesome. All right. Luis asks, how do you identify the teeth to the shark?
Well, each species has very specific shape and size. So even nowadays, there are some techniques and manuals that allows you to identify the species by these characteristics. So there is people that measures all like the parts of the shark teeth and can identify the species.
Awesome. All right, well, one more question. Lasotantini asks, says, interesting talk, thank you. Where do paleontologists split the evolution of whale shark-like filter feeders from the predatory shark evolution?
That's a very good question. I'm not sure. Probably it comes, well, we know it's one of the most recent species according to the evolutionary time, but we don't know exactly how they turn to that. It will be a very cool project to research on.
No, really interesting. And I wonder if in the past, like in the history, if they had, if we had, say, filter feeding sharks or these kind of, non, apex predator type sharks or anything like that, if we wouldn't be able to find them as easy because their teeth may be so small. Like if you think of the teeth of a whale shark, you know what I mean? And if you have no reference of the jaws or anything like that, and you're only basing size on the teeth, you know, you may think that these tiny little teeth are just some little mini shark, you know, or something like that.
Yeah, that's a good point.
I wonder.
Yeah, probably. Well, we know there are other filter feeders like the basking shark, but I don't think they're related. So probably in evolution, there are some species that adapt to the environment. At the end, they finish doing the same kind of food habits, no? But yeah, it's super interesting.
I find it really, really cool. Like the whole concept, like in convergent evolution and everything like that, is really, really interesting. And how you see different animals evolve with similar traits, but at the same time, but not from the same lineage. Like they evolved it completely, essentially on their own. You know what I mean? On their own way of doing things and all that. Super interesting. Awesome. Well, that's all the questions we got. It looks like we got through all of them. If no one has any more questions, thank you so much, Frida, for helping me today and joining in and everything like that.
It was a pleasure.
Awesome. It was great to have you again, as always. And thank you, everybody, for tuning in today and all that. Tomorrow, we've got the shark conservation course going on. Then on Monday, we're back with Ocean Stories with Ted Cheeseman from Happy Whale. So we look forward to seeing you guys. Have a great weekend. If you're joining us for the shark course, I'll see you tomorrow morning. Otherwise, have a great day. Take care, guys, and we'll see everyone soon. Stay safe.
Bye. Bye-bye.
Bye.